Now that we know what a discrete random variable is and how it works in a table form, we need to know how to find the mean. Now this formula should be looking a little bit familiar to you because you already learned this formula in chapter 3, section 3.3 to be precise. You want to add up all the values of x times the probability of x. Now, we'll talk about how that works in a second, but let's look at this for just a second. This is mu, not x bar. So why? Why isn't it an x bar? And the answer is, well, because it's a probability distribution, it's assumed that this is how it's going to work for the entire population, because probability is really about all future events, all of them, right? And since it's about all of them, it has to be a mu, right? Because you're assuming that the probabilities you come up with are how that population of future events is going to occur. Now, the expected value, remember way back in chapter 3 when I first taught mean, I talked about calling the mean the expectations. You'd say, I expect, 4 kids, give or take 1 kid. I expect an 80% on this test, give or take 10%. So that expectation is what the mean actually is. In other words, as we perform more and more and more experiments, as we keep doing this, the mean of those results should get closer to that expected value of the random variable. Right? That mean is that balance point. That's what you expect to happen in the long run, is for that balance point to come out in the data, in the probability. Now we have to compute the mean and standard deviation. I've already done it, but let's go see how to do it, shall we? So I guess I should call this example 1 and 5, or 2 and 5. 2 and 5 here. All right, now again, this is review. We already did this way back. Let's remind ourselves that the sum of these numbers right here is 1. Good to know. Helpful. Okay, now to find the mean, what you have to do is you have to find the sum product. Remember that formula? And you have to tell it what the values are. Now the values are the x's right over here, which is the 4, 5, 6, 7, comma, the probabilities right here, right? 0.121 and so on. Don't do the counts. I know the counts are there, but don't do it. Here's the mean. Boom. Now, if you did do the counts, you're probably saying, oh, Lana, I could have done it. All right, so if you do sum product, if you had done x's, comma, counts, that would have been fine, except it's not the mean, right? Then you have to take that value, 382, and divide it by the sum of those counts that we already found. That's what we were doing in 3.3. Now, what I didn't bother with is the whole the divided by thing here, right? Okay, well, why not? Well, because if I use the probabilities, which are these ones right here, then the sum is 1. So you're dividing by 1 and you don't have to worry about it, right? So in chapter 3.3, section 3.3, we did this, where we would do the counts, right? So we'd say sum product of this column and this column, and then divide it by the sum of that second column, 66. But in probabilities, we don't have to bother because the probabilities should add up to 1. So as long as you use the probabilities, you're golden. You don't need that part. All right, so we've got the mean. Fabulous. All good. Now the standard deviation. Now, as you recall, this is much harder. You got to find x minus the mean. You got to give the mean dollar signs. Better put that in there. X minus mean. Giving it dollar signs. Then you're going to square that and times it by the probability. And again, it'll make your life easier if you use the probability. All right, so let's do it. It's equal to that parentheses, x value minus mean, give it dollar signs, close parentheses, squared, times 0.121. Enter. Now I'm going to go up here, click on that cell, get to the bottom right corner, get to the handle, and drag it down. All right, fabulous. Now I need the sum product of these values. Oh, no, I don't. I think I just need the sum. Let me drag this. Sum. There we go. Sorry, I don't need the product. I was just losing my mind there for a second. All right, so let me put this in brackets so I can... There we go. Now I've got a better sense of it. Okay, so I found x minus the mean, squared it, times it by probability of x. I dragged it down, and I got down here to the sum part. right? So down here I have the sum. Hold on, I'm going to clean up my bars here just a second. There we go. I like that better with no borders down here. All right, now this, believe it or not, is actually the variance. This is even easier than what you were doing in 3.3. Because in 3.3, you'd have to do all that, and then you'd still have to divide by 66. But now, because you use the probabilities, right, we have to divide by 1, which means we don't have to divide by anything, right? So what we just found was the variance. They asked for the standard deviation, but we all remember from section 3.2 that the standard deviation is equal to the square root, SQRT, of that variance. There, right there, is the standard deviation. Okay? So it's actually like a very simplified version of what we did in section 3.3. You've actually done problems just like this in 3.3. The kicker was that in 3.3 it was more difficult because you were having things sum up to something other than 1. In this section, because if you use the probabilities, if you use them here, to find the mean and sum product. If I use those probabilities, all I have to do is sum product and I've got it. And over here, if I use the probabilities, then when I get to the bottom, when I find that sum, that's automatically the variance. No division required. And then I just take the square root of it and I've got my standard deviation. Now, how do I interpret it? Well, I would say that we expect an NBA Finals series to last 5.78 games, give or take 0.962 games. There you go. Now, I know, and you know, that 5.78 games is not technically possible, right? You either get 5 games or you get 6 games in an NBA Finals. But what I'm talking about here is the expectation in the long run. I know 5.78 isn't possible for any one series. What I'm talking about is that over time, this is what it'll average out to. So no, do not round it. Don't go, oh, 5.78, that's 6. No. Leave it 5.78. If you round it to 6, then you've rounded it too much for when you start trying to interpret it for large numbers. So you'd say like, oh, okay, if I had 100 NBA series total, I'd expect 578 games total, right? So you don't round it to 600. 600 would be rounding too much. Leave it at the 5.78. That's what the percentage, that's what the expected value, should work out to be in the long run. All right. Now, believe it or not, this is a really big deal, what we just did. Finding the mean is a huge deal. It is what Bernoulli, who's a famous mathematician, this is one of the things that he's most famous for, because he believed that once people were able to assign expectation, i.e. find the mean, right, because that's what the mean is, for probability experiments, then people will be able to make better decisions. Now, whether that worked out or not, that's another story. So let's talk about it in terms of gambling. So when you're gambling or betting, a game or situation is in which the expected value is 0, it's called a fair game. So fair game is when you don't expect to be ahead or behind. When the game is over, if you keep playing, you should be kind of at the same value you started with. Obviously, casino games don't do this so much. All right, so we're going to have a player pay $3 to play the following game. He tosses 3 fair coins and receives back payoffs for $1 if he tosses no heads, $2 for 1 head, $3 for 2 heads, and $4 for 3 heads. Sorry, $1 for no heads. All right, so I already started it out here, and I'm going to totally have to put it in Excel. Make it its own thing. Here we go. This is 6.1, example 6. There we go. All right. Now, the net winnings. Let's see here. Now, if you're paid off $1, but you paid $3 to play, right? So your net winnings then would be negative $2. You're in the hole $2, right? Ooh, I don't like that. Oh, I forgot about that. All right, hold on one second. I'm going to have to change the format. Right click. Format cells. If you don't make it do this to begin with, then you should be okay. But of course, I'm a moron. All right, so I'm not going to put the dollar signs in. Excel's being smarter than I am, because Excel's an accountant's tool, so it makes negative things red, and then Yeah, don't even get me started. It's a tool that accountants use a lot. Okay, so -2, -1, 0, 1. If you did accidentally follow me along and put the dollar signs in there, that's okay. Just highlight the cells, right-click, format cells, and make them number with no decimal place. And press OK, and then retype -2, -1, 0, 1. Don't give it dollar signs. All right, now what's the probability? Well, we found this way back. Oh my gosh, I'd have to go look it up in chapter 5, but we already found these. This one was 1 out of 8. This one was 3 out of 8. This one was 3 out of 8. And this one was 1 out of 8. And if you don't believe me, it just occurred to me. I could use this. This is sort of like the same tree diagram. It's just with heads and tails instead of successes and failures. So if you count like head is success, then this is heads, 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 tails, and so on. The trick is that unlike an NBA player, the coin is assumed to be 50-50 every time. So you do, 0.5. In other words, they're all equally likely, right? So you go, oh, there's one that's heads, heads, heads out of 8. There's 3 of them that are heads, heads, tails, heads, tails, heads, right, out of 8, and so on. So we learned these way, way back. If you look in the chapter 5 notes, we found them ages ago. Okay, so then they want us to do what exactly? Find the average. Yeah, okay, so we found that part. We're good. Going back. Highlighting. Copying and pasting. Cool. I'll bold them that way. I should have bolded them in here, but that's all right. Okay. Now, assume that the player plays the game once. Find the player's expected net winnings for the profit of this game. See that word, expected? See it right there? They want you to find the mean. So we need to find the mean. Right? That would be the expectation, the expected value. Luckily for us, we know how to do that in Excel. Although, I mean, if you didn't have Excel, I mean, it's the same idea. You multiply each, this -2 times this probability, this -1 times this probability, and so on. And then you add them up. So it's not exactly hard to find. But we are going to use Excel because we can, at least for this portion. So we want the sum product of, and now my array is this, because that's for the winnings. I don't care about the number of heads I get. I don't care about the payoff. I care about my winnings, what I'm going to walk away from the table in. So that's the net winnings column, comma, and then I use the probabilities because that makes my life easier. Enter, and there we go. The mean is -0.5. And now remember that's dollars, so -0.5, oops, negative dollar sign, -$0.5. Is this a fair game? Heck no, not even close, right? Because the expectation, the expected value is not 0. Right? Actually, because the expected value is negative, this is a bad game for the player because they will should be out 50 cents for every gameplay. Right? I don't know why I'm underlining all that. Last bit. If this player stands at that table and just keeps playing and playing 50 times in a row, what should that player expect to be the winnings or profit? And the answer is, well, you take 50 times -0.5, which would get you -$25. So they should expect to be in the hole $25 because it's negative. All right, we'll see more of this expectation in the next video. See you then.